That's because you wouldn't look at my
For those of you who read the newsletter, you saw some of the photographs in there of what I've been doing with this offset turning. Is Lee Carter still here?
Just stepped out.
He was here a while ago. A few years ago, I went to a class, I believe, up at his place. And he had us turning some little pendants, about an inch and a half in diameter. And the way he had us doing it, I learned a lot. But when my wife looked at that, she says, I want some coasters. And she wanted a bunch of them for Christmas presents. And when you have a handful of relatives and you're making 4 coasters per relative, you need to be able to figure out how to speed it up. And that's really what we're going to be talking about tonight, is how to speed that up. Those of you who had a chance to look at it, you've seen some of these up here that are finished. And there's some pictures of others in here that I have done in the past. When I got to looking around for samples to bring in here, I found out that my wife and daughter had taken care of my reserves. My reserve band was 0. So I had to start making some more. I want to start off by getting a little bit of the nomenclature. Somewhat the key to this thing is knowing where you're putting your discs. Now, I think that most of you have heard of airplane pilots traveling from point A to point B. They have a vector, they know where they're going, they know how far to go in one direction. So that's what we're going to be doing here. That's a 4.5-inch circle. That's just what I happen to pick for my coasters. We got it big enough that I can put my mugs in it. The standard coasters they have are too small for the cups that my wife buys. Okay, so there's the coaster, and there's a center down here. It's the center of the coaster. And straight up is 0. Or for those of you who don't like math, let's call it north. And this over here is 90 degrees. Or what direction? Okay, and this is what?
180.
180. What direction is that?
South.
South. And over here is what? 270, which is west. Okay, so that gives us an idea of what direction we're going to go. And the next thing we need to do is figure out how far out we're going to go. So if we put a center of a disc right there, then we could say that that disc is located at 0 degrees and it is up this distance. That make sense? Yes? No?
Yes.
Okay. Now, I encourage you to ask questions. If you don't understand something, tell me. Okay, let's put another one on here. This one I'm going to put the center over here and draw that disc. Okay, where is it located?
90 degrees east.
90 degrees or east and some distance. And that distance, my drafting instructor would have a panic. You're not supposed to draw on the item that you're constructing. You're supposed to have the dimensions outside. So with that, we can go over here and we can start building a table. Now, Frank, where are you? Okay, this is a chart, a table, not a table with legs. Okay? So we can go over here, we can build this table. And we're going to call this the direction. And let's see, we're going to call this in distance. Let's call that capital R. And then let's talk about the diameter of the small circle. We'll use a small d for that. Okay, so if this is our first disc up here, let's call that disc number 1. What direction is it? North, or how many degrees? 0 degrees. And if this distance here is 3/4, what do I put in here? How far up above 0 is it?
3 inches.
3/4 of an inch, right?
3 inches.
No, I didn't say the diameter was 3/4. I said the distance to the center is 3/4.
Okay, 3/4.
Okay. And the diameter of this piece, 1.5 inches. Okay? Now, what would this one be? What's the direction?
90 degrees.
Okay, it's 90 degrees. Okay, and it's 3/4 of an inch. And the diameter is 1 1/2. Okay, let's put another one down here. Okay. And that again is 3/4 of an inch. Okay, what's the direction? Okay. And number 3 is 180. And the distance is what? 3/4. And it's 1.5 inches in diameter. Okay, Dick? Over here. I want you to stand on that X right over there. Okay?
He told me he found a job even I could.
Okay.
Yeah.
Now,
You want me in the middle?
okay, now you are standing on that X. I want you to go to this position right here.
This the top?
That'd be north, right?
Okay. You want me in the north?
North is that way.
No, north here is this way. We're gonna go with the drawing.
Okay. Okay, so you went north, that 1.5 inches. Okay, I want you to go to position number 2. Okay. Now let's go to position number 3. Okay, now I want you to go back to the center again now. And you're facing north, right?
Yeah.
Okay. I want you to go to position number 3. I want you to
turn
go
around. Oh, position number 3. Well, we got 1, 2, 3.
Okay, now you turned around
Yeah.
and walked over there.
Yeah.
So you went plus 3/4 of an inch to scale at 180 degrees. Okay, now go back there a minute. Okay. Now without turning around, walk backwards.
My mother taught me never to do this.
Now you're still facing north. Okay, so you're facing 0 degrees, right? What direction did you go?
South.
You went south or minus direction, right? Now that's key to the efficiency of this thing. So you can look at this a little bit differently. Instead of saying 180, you could still say 0. But he did not go in the positive direction. He walked backwards. So that would be minus 3/4. Anybody confused? Remember, just walk backwards. Instead of going this way, he went that way. Now, the reason that that's important is that the fixture I'm going to show you, it's easy to move back and forth this way, but it's a challenge, or it takes much more time to rotate that thing around. And I'll show you that in a minute. Everybody with me so far? Okay, now the unit that we're going to build today is basically, okay, look at this one right here. Okay? You sit down now. You can have. So you've got the positions here.
John.
You've got one in the center.
John.
Keep me honest. Okay, you got one in the center. So this one up here is number one. And let's see, going clockwise, this would be number two. And number three is this one down here. This would be number four, and this would be number five. Now, you notice I said 1, 2, 3, 4, 5. That's important because that sequence determines the design that you've got. Okay? Now let's look at this one. Okay? This was number one. This was number two. This is number three. Then 4 and 5. So the sequence, the difference in the sequence that you turn these things makes a difference in the way the result comes out. So you can change your design quite a bit just by changing the sequence. Let me give you another example. How many of you looked at these? Okay. These are trivets. These are 6 inches in diameter. The positions of the disc are the same. The sequence is reversed. Now, at this one, we started right here. And then we moved out to these three, then we moved out to the next three, and so forth. So we started at the center and worked out so that they overlay. Whereas this one, we started at the outside and worked in. Now, this guy, these two guys, these were in patterns of 3 or sections of 3, so that's 180 degrees, 120 degrees between those. And that was a pain in the neck, to be honest with you. Now this is a little bit different here. This is symmetrical. So what I did is I set an angle and I did the first one. And I did the second one. And I moved back and forth. And these things show up in pairs. And that makes it a whole lot easier by keeping it keeping them in pairs like that, because that way I can use the +3/4, -3, well, +3/4 and the -3/4. I don't have to change that angle. Anybody confused yet?
No.
Okay. Okay, that's what we're going to do. The next question is, how do you do it? Several of you came up here and you saw all these little discs up here. Well, when you start doing things like this, you start looking at your scrap pile differently. It no longer becomes firewood, it becomes a palette. That's your palette of colors that you're going to use for these things. So what I have a tendency to do is I look at my scrap carefully before I throw it away. If it's got any interesting characteristics to it, I take it over to the bandsaw and slice it up into 1/8 inch thick pieces, 1/8 or thicker. Some of these you'll see up here are a little thicker than that. And I don't care what the shape is, as long as it's larger than the disc that I want to turn. Okay, then,
You turn it around first before you cut it?
no,
Okay.
I cut them in flat sheets. I don't know what size I'm going to want tomorrow. I cut them in flat sheets. You go through my shop, you're going to see stuff laying around up there that different sheets. Okay, now where am I? I have a sack here someplace to scrap it. Here it is. Now the key to a lot of this is making good templates. Ron, is that round? Okay. Just want to make sure. Okay, so I have a lot of these little discs that I've made. And these are made out of hardwood, or not hardwood, masonite or hardboard. And I'm very careful when I make these to make them the exact size that I want. As long as I make them the exact size I want, I can use them as a template and do all sorts of neat things. Okay, where'd it go? There it is. It's waiting for me. Okay, this is my number of the check. This is just a piece of scrap that I turned. And I'm going to use this to hold things with. Now this is dual purpose. I use it on this side part of the time and on that side part of the time. I'll show you how. Okay. Ron, you are in an ideal place.
Perfect.
Okay. Now, if you look at this, everybody know what a step center is? Okay, for those of you that aren't nodding your head, yes. It's spring-loaded. Okay? So that means that I can jam it into things without really destroying. That's key to what I'm doing tonight. Okay, I put this on here like so. And I got to get it in the center. And I bring it up, and I don't tighten it up completely. Let's see, let's get that centered so I get the right figure in there and get everything squared away. Then I tighten it up. So that's held in there by friction. If we don't have good friction, Ron's going to get a lap fall. Okay? Now, the key to this is that you ever heard the term rub the bevel? I see a few people nodding their heads. Anybody that hasn't heard the term rub the bevel? Okay. Okay, what we're doing is that the key to it is when we come in here and turn this thing, gotta get the right angle in here so we can get to it. If you rub the bevel properly, your resultant disc will be the same size as your template. Now, by that I mean you've got to go straight across. If you do that way or that way, it's going to be tapered. Sometimes that's a good idea, but you generally know. Okay. You ready, Ron?
You bet.
Notice you don't have a helmet.
What's that?
He doesn't have a helmet, you notice that.
Good one. That's right, that's right.
Ron noticed that too.
Jim went that way on him.
Yeah.
I'd move if I were you, Ron.
No, I got my glasses on now. Shoot.
His nose sticks out there to block the rest of it.
Yep. Right.
Can't hurt the rest of it, right?
Nah. Yeah.
Okay.
Okay. You gotta have that thing tight. Let's try it again. Now by rubbing the bevel, I can go straight across and I can get a perfect fit. No difficult. How many of you used templates before? 2 or 3, 4? That will, if you've got several things to turn, that will give you a tremendous leg up on getting what you need. And you'll notice that it slipped a while ago, kind of burnished it a little bit. That's okay. That'll either be on the bottom side, and you'll never see it, or it'll be on the top side and be turned around, turned away. Any questions so far?
What was your template made out of again?
I like to use masonite or hardboard. Because
You just go ahead and turn your template then?
Yeah, what I would do is I would stick that blank in there just by itself and crank this thing down and then mark it with a pair of dividers and work my way down very, very carefully because the precision of that piece is very critical because you're going to be making many more based upon that. Okay, that's for larger pieces. What do you do if you got something that's really small? What's this? 3/8 of an inch. You gonna do that using this technique? You can, but it's a real pain. What you can do is you go down to the hardware store, and those of you who are furniture workers know that you can drill a hole, put a screw in, and then you can backfill it with a plug. Glue it in place and trim it off. And that's what these are. These are plug cutters. There's different styles here. I'll pass them around. Just be sure I get them back. But these do a real good job of cutting plugs out of your disc. Now what I do with those is I'll take a sheet of them, a sheet that I want several of these things with, put that in a drill press and just go after it. Now depending upon the thickness of what I'm doing, I'll either drill all the way through or I'll drill part way through and then break them out later. And this gives us a series of well-defined, known size discs.
You call these plug turners?
Plug cutters.
Plug cutters.
We're cutting out a plug.
Okay.
Typically, most drills, the waste is in the middle. In this case, the good stuff's in the middle. Questions so far? Yes.
How do you trim your plugs to your 1/8 inch or whatever you're using for thickness?
Don't worry about it.
Okay.
Pass this around. If you'll notice, some of these guys are quite thick. But I glue that thing in there and glue it into my base. My gouge is real good about thinning it down. Because when I start turning them, well, this one, for example, this one is a little bit proud. That's okay, I'll turn it down. The other one, I didn't cut the inside out as much, so it's a little bit, they're a little bit recessed. Okay. So the next question is, how do you go about making the recess so that everything works well? Well, you've got the old conventional way. You take a pair of dividers, you figure out how wide you want it, and you put your disc on a mandrel or something like that, and you mark it. And then you take a scraper or something like that, and you cut in there. That works, but it's a little bit inconsistent. So what I did is I thought about it for a while, and I came up with a different way of mounting and cutting those recesses. And this is what I came up with. This is my fixture. This is the second generation of the thing. It says January 2010, so it's been around for a while. Basically, you'll see this in operation. Basically, you'll see that these coasters are going to be put on here with double-sided turning tape. And then I can loosen these bolts up and I can move it side to side. So that's going to give us this direction here. Are we moving left, right, how far, and so forth. I glued down a scale, and you think that says 3 right there, but that's really a 0. What I'm really interested in is the graduations. So what I did is I went out here and said, okay, that's 1 inch. So moving it that way moves it 1 inch, 2 inches, 3 inches. And then I can ignore the rulings inside the markings inside the ruler and go ahead and use the individual divisions inside. You see that, Dave?
Yes, sir. Well, you moved it.
Yeah, there you go. So I've got plus direction going one way and minus direction going the other. Then over here, if you can get in on that, I've used the indexing on my lathe to go around and mark this thing. And it turns out my lathe has 15 degrees increments. So there's 0, 15, 30, and so forth. So I can rotate this. So by rotating this and then moving the slide back and forth, I can put any point on this disc at the center of the lathe. Okay? Now, let's go ahead and, okay, on the back side, I could use a faceplate. I came down here and looked for a faceplate, and I found this neat little thing called a faceplate ring, I believe it is. And I don't know if they still got them around, I'm assuming they do, make them over. And put that on there, and it's never come off again. Pretty much stationary. Questions so far?
How do you move the thing in a circle? Get the different angles.
See this hole right here?
Yeah.
Okay. If I loosen this up, I can slide this over so that the screw, 1/4-inch screw that is screwed into the insert lines up with that hole. So this disc that's got the markings on it has an insert, brass insert screwed into it. It's got a 1/4-inch bolt in it. And I access that and I'm moving it over to where I get to this hole. And that takes a little bit of extra work, so that's why I try to avoid changing the angle any more often than I have to. Okay, you'll also see a series of holes here. These holes are a 1/2 inch apart, again drilled with the drill press. They line up with these holes over here. You'll also notice that those holes are staggered. So it gets back to the idea that if I want to move to a particular location, like I'm at 0 right now, I'll move over to that point and I'll stick that through there, and I am exactly at that place. It makes it very repeatable. So this one will not go through because there's no hole there. But if I move it over a 1/4 inch, there is a hole. So in fact, we're jumping back and forth between these two holes every 1/4 inch. But that allows me to get some repeatable positioning on there. And that's what allows me to get the accuracy on these pieces.
John,
Yes.
when you said you put that scale on the other side to make your 1-inch markings,
Yeah.
are you saying you wouldn't even need the scale now because you're only using 1-inch increments?
If I could, or 1/4 inch increments.
Okay. So
If
you
I
didn't-
could keep track of it, I could do that, but mine, I don't like to count, I like something labeled, so I can keep track of it. And there's going to be some designs where a 1/4 inch increment is not right, I need to go 1/8 of an inch.
So the scale does have to be
The scale allows me infinite position.
there. Okay.
The holes quantize positions at 1/4 of an inch.
Okay.
Okay? Everybody clear on that? Yes.
That's a very clever design for your jig. Do you have drawings of that or somewhere that we could copy?
Yes and no.
He sells them.
Okay, you are not a plant. It turns out that I wrote an article on this thing back in 2010, and I've got that full article which describes this. The problem of it was that when I got through writing the article, it was too long. It ran about 15, 20 pages. And I've learned a few things since then. I can go back and redo that article and get a lot more condensed and get it a lot simpler. And by you guys asking questions, that's going to help me refine that article. Because I know what's important to you as opposed to just what's important to me. Okay. These are my discs. I'm going to cut this in 4.5 inches. Here another template. I'll be using that to position the thing. Okay? Now, in order to hold it on here, what am I going to do? What?
Tape.
Yeah, I'm going to use double-sided tape. How many of you have ever used double-sided turning tape before? Ah, a bunch of you. So you know all the tricks, right? You know what not to do. You know what to do, right? I bought this roll of tape out here, must have been around 2010, 2009, and I'm still working on it. How much tape do I use on here?
Just an inch.
What?
Inch.
Where do I put it?
Just a little more than
What?
Just a little more than you need.
Give Ronnie his glasses back.
Now,
Use enough to hold it.
yeah, but I put it out here at the perimeter. If you want to waste your tape for this, put it right in the middle. Because the primary forces that we're working with here are torsional forces. And you know, when you're using a wrench, a nut, the longer the wrench, the more leverage you have, the better off you can do. Get a real short wrench, it can't do much for you. Well, what we're doing here is we're putting this out at the edge, so that's like using a long-handled wrench. Putting a piece right there in the middle is a waste of time. Okay, what's the next thing important?
Peel the back off. Take the back off.
Yeah, take the back off. Don't take the backing off, it isn't going to do us much good, is it?
Are you a plant, Dave?
Sounds like Dave knows that from experience.
I think it's an animal as opposed to a plant. Okay, now different people have different ways of doing this. This is the way I do it. I take an X-Acto knife or some sort of sharp knife and make a little angled cut that comes right on off. Matter, Ron, am I doing it right?
I just want to see it.
Oh, it's coming up there, those little ears. The trick is to cut through the backing and not go all the way down to the wood. Okay. Now this is the most difficult part, getting all this stuff lined up and get it on there. Hold your mouth just right, everything.
Yeah, but you just, my language.
That in the center.
Yeah, you should think that's really
Oh, that's good enough, Ron. Now, the next thing is to clamp that thing down tight. And I do mean tight. Now, those of you that don't have much experience with this, Lee Carter taught us that you got to put heavy pressure on there for at least 5 minutes. You want to sit here and watch that for 5 minutes? I got better things to do. So what I'm going to do, since that's being held in place, I can go ahead and turn this outside. That tight enough, Ron?
Tighten more. Yeah. Yeah.
Okay, conventional way of doing this is that you would now go through there and you start cutting that round and take your caliper and measure it, turn it. Well, we're going to use the idea of bevel rubbing again. I'm going to get things just right and there we got some clearance. Got your safety glasses on?
What tool is that you're gonna use?
This tool?
Yeah.
Oh, yeah. Essentially, this is just like faceplate turning or bowl turning, such as that. I used a spindle gouge when I did that desk, like trying to get it real smooth and so forth. But this is nothing more than a bowl gouge. And it's sharp. My thumb told me it's sharp. So I got a Band-Aid on there. Determine whatever speed you're comfortable with. And incidentally, I turn left-handed as much as I do right-handed. I turn left-handed, the chips go away from it. Left-hand bevel, and try to make sure that I don't overcut and cut it straight across. When I make that final cut, I quite often like to stand behind the fire so I can make sure I'm doing it straight. That's probably good enough to go on.
So you never grind the heel of any of yours off, whatever, you want them as long as possible on the bevel then, right?
This heel here,
Yeah.
if I'm doing the inside the bowl, I'll turn it off.
But for doing this, you want it as long as possible, don't you?
For this
Depending on the
particular
thickness.
guy, yeah. Now, if you look at this guy, I did not have the heel ground off, and you see the consequences. You got all the little ridges in there. Everybody understand what we're talking about? Okay. Now, how thick do I make this thing? That's thicker than I need. How thick do I make it? Anybody want to guess?
3/16.
Too thin.
5/8.
Okay, let's draw a picture. I have people that tell me that I can't talk about drawing pictures. So it'll help you understand what's going on. Okay. Here's going to be our finished coaster. Okay. And it's going to come down inside and come across here. Hopefully it'll be straighter than that. And then we're going to have an inlay in here. What have I left out?
Bottom.
What?
Bottom.
Well, what I left out is this little point sticking down here from my Forstner bit. That's one of the penalties we have to pay for when we're doing our using the Forstner bit. If you look at this bit, it's got that point right in the middle. And you have to allow for that. That's an extra 1/8 of an inch. It's a real pain in the neck. Now here's a cut that I made using, this one's an 1 3/8, I believe it is, a little bit larger than that. But the 1.5 bit that I'm using tonight, I modified. But this before I modified it, you look at that thing, you see where that center point comes in here. It drops down an extra 1/8 of an inch. So you have to allow for that. Okay, now I told you guys to look for the flaws. If you look at this one, if you look at the back side, you'll see where it came through. How many of you caught that? Nobody? Oh, okay, at least one person did. Like I said, if you don't tell people where the flaws are, they'll never know.
If you put a drink on it, nobody will know either.
He said put a drink on it, they will know. Okay. What I have done is I've gone in here and modified this Forstner bit. This is the one I'm going to use tonight. And the center pin here is been shortened quite a bit. Now, as long as I'm using it on a lathe, that's okay, because the lathe is going to hold it in place. And so if I put this in a hand drill and try to freehand drill a hole for doing a lock set or something like that, it's going to be a little bit difficult because it's not going to have enough support to center the thing. The lock sets, you go completely through. This thing I'm using is a blind hole, okay? So what I'm going to do, we'll pass this one around. You'll notice this one's a little bit thicker than the first one we're passing around. What I'm going to do is I'm going to make this height right here 9/16. Okay, and then this recess here at the final piece is going to be 1/4, and therefore allowing for that nipple sticking down the center point. This distance is going to be, let's back up. I'm measuring from the top here. Distance from here to here. That will be a 1/4 plus an 1/8 or 3/8 of an inch. So that allows for space in here for this center point. Now, if you grind it off or shorten it like I did on this one I've got over here, it gets a little bit friendlier, but just be careful whatever you decide to do. Okay? That been setting long enough, Ron?
Pardon me?
Has that been setting long enough?
Not yet.
Not yet. Okay, just for you, I'll put that back on there just to hold it. Okay, let's put this back up there. And what I'm going to do is I'm going to go in here and mark this. I know this ruler is a 1/2 inch wide, and I will mark it an extra 1/16. So there's my thickness. If I had my carpenter's pencil, I'd use that. But, this guy is too fragile to turn the lathe on. Well, that's running. Okay. Ron, you ready?
You bet.
Supposed to reposition two of those. At home, I've got a big bar plate, turn it off, just take the knee and bust that crash bar. Don't have that here. I don't know, Ron, you can do the vibration there. You don't have that kick drop.
I think you need more tape.
That's it?
Yeah.
Okay. Now I've got this as a depth gauge. You can use anything you want to. I just happen to use this one. And I put a bar on there, glued it on so that it will span across my bowl, or my coaster, whatever. And you notice I'm not quite down a quarter of an inch. That's okay. Doesn't need to be yet. That gives me an idea of where I'm at. Okay, now, our first cut on this is going to be 0 at plus 3/4 of an inch, right? Right, Ron? There's my 1.5" Forstner bit. Okay. Now I want to move 3/4 of an inch. Now I can rely upon this poor light and get the thing in there. And I can also make sure that I'm at the right place. So now I know exactly 3/4 of an inch and I can reproduce it. Okay?
Did your head hurt after you designed that jig?
I lost some sleep trying to figure it out.
I bet you did.
So patent pending?
What's that?
Patent pending?
I'm not understanding.
Patent.
Pending, no. When I was with HP, we were talking about that patent lawyer one time. Kent can probably tell you about it. But a patent is only as strong as the strength of your pocketbook. So if somebody infringes upon your patent, you have to go after them and you pay the legal expenses. And if you win, great. If you don't win, that's something else. Okay, now I'm setting this for 3/8 of an inch. Okay, and slow this thing way down.
Take that bolt out.
Yeah, you want to pull that bolt out?
Why?
Or it gets right?
Ron, you have your safety glasses on. I hate to admit how many times I forgot to pull that bolt out. Okay, now, it's extremely important that your Forstner bit is sharp. Because if it isn't sharp, you'll rip this thing right on off of there. Which reminds me that I forgot a step. If we rip the thing off, we want to recover. You see this mark right here on 0? Okay, I'm going to put a mark on a blank right there. Now, if I rip that thing off, I can return my offset to 0. I can use my template and fit right on there, use my center or my life center, and I can put it right back where it belongs. Now, you want to ask why I figured that out? This one here, this large disc, I have to look, it's about a 3 1/8 inch Forstner depth. And if that thing isn't sharp, it comes right off. Okay. I got the bolt out, I got my mark on there. You ready to catch it on?
No.
Now I can go in here and I can measure it. And it looks like I got about another 1/8 inch to go.
If you have, because you're gonna finish turn that when it's done, if the thickness of the disc or the depth of that hole is not exact, it's not gonna make any difference, is it?
As long as it's deep enough and didn't all the way through.
Right.
It isn't critical.
Yeah, okay.
It isn't critical at all. Now, one of the things I've learned is that if you look at these Forstner bits, they've got teeth on the side, at least this particular style does. And you get a pretty good idea of how deep you are by watching that, watching those teeth. And initially, at this point, it's pretty much trial and error. You go a ways, you measure it, you go a ways, you measure it. About 30 seconds, Ron?
Pardon?
About 30 seconds an inch?
Maybe. You're almost down to the tape.
Now, another little tip is when you're using these Forstner bits, I said you gotta be sharp. You got 2 cutting edges on there. Typically, one cuts, the other doesn't. Here we go. So what happens when you run into that situation and you want to sharpen it, I will usually put an X on the side that is cutting, because that's the only side that needs to be sharpened, because the other one isn't doing anything. Okay. Here's a good candidate. Let's see how well it fits. Fits reasonably well. That one fits a little bit loose. Now, you can get these things out using an ice pick, or you can use a skew chisel.
Use a piece of your double-faced tape.
It takes too long.
And waist tape.
I'm going to try a different one.
He's proud of that. He's proud of that tape.
Now, see, that one fits a little tighter. The other thing you can do on these, remember when we use that disc to cut it across, sometimes it isn't straight. Sometimes it goes up, sometimes it goes down. So if it fits too tight this way, flip it over and try it. Okay? Now, I'm using CA glue. I've had good luck with it, but since I've started doing these things, I've used CA glue and a lot of other stuff, and I decided I don't like it because it doesn't last long enough. But for this purpose, for this demo, having epoxy set up takes a little bit too long. Okay. Now, there's some supposedly tricks to this. Squeezing the thing and filling that in, starting around the edge. Incidentally, did you find the other error that was made on that, one of those coasters?
Yep,
What?
the disc was too small, or else the hole was too big.
Yeah, yeah. So what he's saying is that the disc fit too loosely. Now you notice that I keep turning this thing, because if I don't keep turning it, the glue's going to run all to one side and run out. So, now the grain direction that you have on these things makes a difference. When I first started doing these things, I didn't match up the grain that well. And I want to make sure that that's in there good. Hear that, Ron? Squeezing it in there is nice and tight.
That was the tape coming together.
Okay, now, at this point, I usually take accelerator and hit this thing. Now, remember, the accelerator only accelerates or hardens the stuff that it can touch. It doesn't do it any good underneath. But this is good enough for what we're doing now, okay? It gets you started. But the main thing you want to remember is that that glue that's underneath there is not set up. So when you start turning, be sure you have your face shield on, because you don't want any glue, especially when you're drilling these holes. You don't want any of that unset glue coming out in your face. Okay, disc 3, where's it at? 180 and 3/4?
Negative 3/4. Minus.
Okay, 0 and negative 3/4. You agree with that?
So to have infinite variability or whatever, have you ever thought about putting a cross slide on the, instead of using Forstner bits or whatever, using a cross slide with either like a Fordham or one of the little micro carving jigs or carving tools with a bit in there, so you can kind of get anything you exact.
Sounds like you're talking about a milling machine when you start doing it.
Almost.
No, I don't want to keep it simple. Let's see. There we go. There. That's especially important when you don't have real good light. Or you start getting old like Ron.
Got that right.
You can't read the small divisions.
Nope.
Now, this is a relatively simple design that we're doing today. But if you were doing something that was more complex, like those spirals over there, then all of a sudden, hey, 1/4 inch quantization on your spacing just isn't going to cut it.
damage.
Right, Ron? Now, I'm looking at the teeth on the Forstner bed, and getting a rough idea of how deep they are. And if it goes just a little bit deeper. What's that?
Isn't there a gauge on the quill?
Yeah, there's a gauge on there.
Why can't you just go from 6 millimeters to
Takes too much thought. What you wind up with is that gauge is relative to something. What's it relative to? Well, you have to go down there, and it's like at a machine shop using a milling machine. You have to go down there and figure out where it's just starting, and then you have to look at this and read it, and it can be done that way. Need about another 30 seconds, Ron? Look back. If one was real smart, you could figure out what the turn per inch are on the threads, depending on the revolutions to go. Ron, you went 16 to, no, per second too deep.
Use a thicker piece.
What's that?
Use a thicker piece.
I don't even care about the thickness as long as it isn't too critical. I'm more concerned about whether or not I made a hole through the bottom. I'll do it in this future.
What do you want to for?
Skew chisel. Put it down somewhere.
That's great brain.
Nope, that ain't. Right.
There it is.
I was looking for something a little bigger.
Once you get that edge up, you can use it to pop it out of there.
See, the tape would have been faster.
What's that? There we go. Now, we know that we're going to cut this out in here in the middle. So if I've got a flaw in my disc, I try to arrange it so that it winds up over there. Now, if you can look, you see the precision of what we wound up with. This disc just touched that one. It's in there where we want it. You agree, Ron?
Yeah.
And this one fits a little bit loose, this disc. So that's why we've got the, I use the thick CA glue, because hopefully it will fill up the gap. Now, if you have a gap like in that one over there, I haven't repaired it, but how would you repair that?
Fill it.
Fill it with what?
Turquoise.
Sand.
Bigger disc.
I didn't know I had that gap until I got through.
Sand your dust.
Yeah, I use it with sanding dust. No, it fits tighter now. Okay, all I did was drill a hole in here such that the this outer rim here fits back against this unit. I've been known to take some of these things that didn't want to squeeze in there, got a little bit too tight. I've been known to take a wooden mallet, a little bit of help, tap it in there. Okay, now comes the fun part.
John, do you ever use white glue?
White glue?
Yeah, wouldn't that hold that disc in there?
I could probably use white glue. I haven't tried it. I thought about doing it tonight because I don't like the smell of that stuff, but I don't know for sure if it will set up quick enough. I know that when doing segmented turning, you can get that stuff to set up too quick. Okay. Now here comes the fun part. Where's our next disc go, Ron?
Pardon me?
Where's our next disc go?
93 quarters and 180.
That's the one we just did.
That's what
Oh.
we just did. 90, 3/4 of 90.
90 degrees.
90
Plus
degrees
3/4. Okay, so, I think it was Ray that asked earlier, how do you get this thing to turn? Well, that's what we're going to do now. And
Turn the thing over.
what's that? Can I get the ratchet turned right? There's 90. I told you earlier that I marked these 15-degree increments off using the indexer. I took this thing off then and used a protractor to get additional 5-degree increments in there. So I've got 5 degrees of resolution in here. That's been good enough for everything I've been doing. What distance, Ron?
Pardon?
What distance?
3/4.
Okay. I think now you can see why I'd like to use that negative distance so that I don't have to make that angle change that often. So if you're making a bunch of these things, you only have to make the angle change once per disc, once per coaster.
You have about 15, John. About 15.
Yeah. What's that?
You have about 15 left.
15 minutes? Okay, let me make this one cut. There's something I want to show you here. Now, you notice before, I was always going in there and measuring the depth. Now I can take advantage of what I've already done. If I watch closely, I can tell when I drill through those other blanks.
Your bolt's in.
Shoot, I was hoping Ron had to catch that.
That's why I have on wearing the safety glasses. Okay, now I can back out, and you can get a shot in there. You can see I'm not down as far as the other discs yet. That's I can go down until those other discs are done, and I don't have to measure each time. You there? Okay, any questions so far? Everybody can go home and do it, right?
You're gonna make us all a jig for by next month's period, right?
Oh, I wasn't planning on making you these jigs. Okay, now, at this point, I'm going to cheat and jump ahead, because you've seen everything so far, right? You've seen the glue dry, in effect. What I'm going to do is I'm going to move everything back to 0. At this point, I would move this to -3/4 and put the next disc in. Then I would move it to 0 and put the center disc in. Oops, that's the wrong one. Makes a difference. That's why I got that scale down there, so I know exactly where I'm at. And then that was a guesswork. Okay, then we move back to this position, which is 0, 0. Actually, we're 0 radius and 90 degrees. But who cares? It's still the center. And we drill the center one, put that one in. And then we have something that looks like this. Skew chisels are great tools.
Great on a paint can.
Okay. Now, one of the challenges you have with any turning project is once you take the piece off the lathe, it's difficult to get it back on such that you can do something useful with it. Right, Harry? Okay. When I'm turning a bowl, one of the things I will do is that as soon as I mount that dovetail in my chuck, I go in and make marks on it, and marking jaw number 1. That way, if I have to take it off or something, put it back on, and I've got it, I know where I'm putting it, got it lined properly.
You know, if you went through where you could see it on the bottom, you could always get a piece of those, like those lid openers, and you could cut a piece of rubber and put it on the bottom, and
Sure you could.
kill 2 birds with 1 stone.
Or just don't tell anybody.
Oh, they're gonna turn it over.
Well, that's an imperfection in wood, did you know?
Okay.
That's not a mistake that
Put
I
a
made.
belt on it too.
Or do the bottom side.
Huh?
We thought it looked nice right there.
Yeah, if it was in the center, it'd be fine, but if it's if the others are that way, you're gonna have to do them all that way, so you'd be gonna send it
Bring it
to
in.
Don't look like epoxy.
Getting too big a hurry, it's not releasing right. There we go. Gotta have something for the cleanup crew tonight, right?
Sure.
This particular fixture, the diameter of the offset for the individual discs is limited by how far you can move this slide. So with that in mind, that's why we've got slots in both the slide itself and the slots in the background. And so that helps here. Okay, now here is the Ron, you're holding your mouth just right.
You bet.
Okay. This is a little bit easier this time because the disc and the blank, or the template and the blank, are both the same size. Still takes 3 hands though. Okay, get those lined up just right. That feels about right. Now I'm going to crank that down and let it set for a few minutes. Anybody got any questions for letting that adhesive sit up? No questions? What's that? You know, the bolt's in there right now to make it as long as I don't turn it on. It's not unusual for me to forget that thing.
What kind of truck was that had the flexible center?
What kind of what?
What was that truck that had the flexible center that you're using? What's the name of that?
The center here? It's called a step center.
Step center?
STEB. That's the brand name. There's some generics out there that they call multi-point centers, I believe it is. But as is typical, when you've got a brand name and you've got the knockoffs, the brand names are usually better. Okay. Now while that's setting up, what I can do, I don't think I told you this, but the back side of this thing I sanded before I ever started. And that's probably around 220 with a random Oracle sander. That allows it to set in there good, and it also minimizes the work I have to do when I get finished. Okay. While I'm still holding that, I'm going to spindle gouge because it's got a small point. I'm going to start rounding over the edge. You don't trust me, Ron?
I do. You told me to be safe.
This is not critical. You can put whatever shape on it whatever you want. But basically, you can pretty well take the blade out while still on the blade. Question? 4 minutes. 4 minutes? Okay. Well, at this point, I've shaped the outside. I can sand that. And I can go in here now and face off the inside. And essentially we're finished almost. Must take light cuts when you're doing this. Now when you're doing it, at this point, what we're looking for is a smooth surface in there. You notice I didn't worry about cleaning off the glue or anything, I'm putting in the disc. So at this point, we're just going to take the, smooth it down, and we have time to make sure it's a 1/4 inch down. Needs to be sanded, check for depth, and we're done. Questions?
What do you put on there for finish most of the time?
I've been using tongue oil for finish.
Tongue oil or tongue oil?
What's that?
A blend, like a blend tongue oil or just pure tongue oil?
I use the Minwax tongue oil finish. The concern that I've got is using it as a coaster is going to be subject to moisture. And I don't want to use a film finish like a varnish or polyurethane because if you get a scratch or something, it's hard to repair. With this, you can just buff it out and go from there. But I would sand this down to at least 320 at this point.
I've got a question on your jig.
Sure.
How many of those did you make before you finally ended up with the one that you like and works?
The first one I made is essentially the same fixture except that it wasn't round, but it came over just straight across like so. And I did the preliminary work on the article for the journal, and I said that 2x6 setting out there spinning around is not going to be very safe. So I went ahead and rebuilt it for this one, And it's essentially the same as the other one. It's a little bit larger, a little bit nicer finish and stuff like that.
Okay.
But it's essentially the same thing, just not quite as creative. Other questions?